thanks you for the host and this very honoring moment to give the opportunity to show our work to you. And Dr. Eric Hamber will help me to answer the questions during and after the presentation. My name is Shen Hao, come from the Hong Kong University, and I'm now a PhD student. We did a work called the Understanding Learner Behavior through Learning Design, Informed Learning Analytics. Here's an overview of my presentation, starting from background and then research questions, context and methods, and then analyze the findings and conclusions. Very simple one. So why we want to do this research? Because in the last decade, there are many inspiring findings have been found using linear analytics, using LA. And but people found that sometimes it's difficult to understand and interpret of the outputs of the LA because it's like from the dashboard or some other some other results. Some scholars pointed that learning analytics is about learning. So we need to use learning theories and learning design features to understand the outputs from LA. So it's a very interesting field to investigate it. And the learning behavior we are going to study is called the learning result access transition. We define the transition as a sequence of the connected result traversals. It usually starts from the trigger and end in target results. If we put all the transition together, we can get a learning trajectory. It is a path along which learning may proceed. And of course, it consists of a sequence of transition. And it's very interesting because, learners can decide their own own learning path in the MOOC. They could follow the natural order of the course, and they can skip or review the resources during their learning process in the MOOC. And there are two questions we are going to research. First is, do learner behavior pattern reflects the learning design features of the MOOC? And we look further into the learning design properties if the resources are are likely to serve as a trigger or targets. And we want to look at the associations in the targets and triggers depending on the learner's background and their performance. So the data we collect comes from the course Introduction to Computer Science and Programming using Python from the edX platform. The course is designed with three resource types: video, finger exercise, and problem set. And we only select a very small sample group from the all enrolled learners because in this group the learners all completed the course with a score, and they all participate in the pre-class survey so that we can know their background, their previous experience of programming, and of course their performance. And there are three methods we used in this study. First is the content analysis. We use content analysis to document the learning design features. We use a framework of the revised Bloom taxonomy. There are two dimensions. First is knowledge type, and then cognitive process level. There are four types of knowledge: factual, conceptual, procedural, metacognitive knowledge, and there are 6 levels in the cognitive processes, as you can see here. And then we create the we call it the learner resource access transition matrix. As I mentioned earlier, the resources are designed in the learning sequence, but the learner can decide their own path. So we define the one access transition starting from the departure node called nj to the destination node called ni. So we can use the coordinate nij to represent such a transition. And so if we put all the coordinates together, we can get the square matrix. In this matrix, each element aij indicates the frequency of the access transition ninj, and then we can draw a heat map to realize such a learner resource access transition using matrix data. And the third one is social network analysis. But we only adopt the notion of a degree from SNA. It means that we do not draw the SNA map in this study. So we use the in degree frequency to represent the number of transitions going to a resource, and out degree means the number of transitions leaving from a resource. The findings. First one is about the features of learning design in this course. We've found there are three knowledge types in the videos from the Bloom's taxonomy, and we further add a type called overview and summary, because these resources usually introduce or summarize the whole session or whole week in the resource. So, and we do not find we do not identify metacognitive knowledge. It does not mean there is no metacognitive knowledge, because we found there are the metacognitive somehow is spread over all the course, so we cannot split it out of the sorry. So at last we in the we also found three lowest level cognitive process in the physical exercises, and but we only label the problem set as a complex performance, because students need to use all the cognitive skills to solve a certain problem. So here's the heat map we draw for the first research question. As you can see, there's an obvious diagonal across the map. It indicates the natural order of the course design. So students could somehow they watch video from video 1 to 3. So that is a natural order. And we also see there's a review resume events. It's a mirror image around the diagonal. So, and also the mirror image will turn into the means the clustering of the blocks. So it means review resume events in and across the sessions. And for the second research question, it's a little bit complex. So we break it down into three questions. Basically, we are looking at the two kind of variables. First is access frequency, and the second is in-out degree frequency. And there are three kind of factors. First two is about the learning design features. First, resource types, and then the knowledge type and the cognitive process level. And the last factor is learner's background. Sorry. For the first question, if we look at the access frequency, we found the students with higher score or higher educational background, or those students who knows programming will use course resources more frequently, but it's not frequent. It's not significant for the videos when comparing their previous experience of programming, and also it's not significant for the problem set and examinations when we look at their educational background. If we look at the variable of in-out degree and frequency, and then the factors are the result type and learner background, we found it's very significant for the scores, but it's not significant if we comparing their previous experience of programming. And we also found that no, it's our interpretation. The higher performers are aware if they encounter difficulties, and they are better at using video to resolve the difficulties. And it's quite interesting also. Learners' background of programming do not affect their in our degree frequency. The third one still it's about in our degree frequency, and the factors are from the Bloom's taxonomy and the learner background. So again, there's no difference in previous programming experience, but it's very highly found that the overview and summary videos are highly served as triggers or targets. And also the higher students with higher scores and higher education background had highest in and out degrees. For the complex performance, the out degrees are much higher, except for those with higher educational background. It means that students are going from the problem side very frequently, except for the non-higher educational background student. So we can draw conclusion. First is about the matrix. It shows that how learners go from one result to another. We can see the review and resuming events in and across the sessions, and also we can see that learners follow the intention of the course design. And for the second question, the in-out degree reflect the importance of the targets and triggers. So videos are very important because they serve as trigger and targets for learners for the higher scores or higher educational background. And the better students are better at when they choose the patterns to in the different knowledge type and cognitive process level. And previous experience in programming seem to not influence the resource transition behavior. Thank you. I'm a little bit, not a little bit. I'm very nervous. Thank you. It's my turn.
Oh, thank you for your presentation.